Hello, everyone. Today we're going to be working on the Lab 2, which is Code With Me Part 2, and that focuses in on SciBooks 3.4 to 3.10. So inside of Google Colab, I do have the actual information here, but before we get started on the actual tasks, I'm going to go ahead and go through some information since this is going to be recorded here. So in Python, um, yesterday we mentioned a bit about list and strings and how we actually can use lists as well. And so for this, as we're getting into the other part of the data structures or collections, I just want to call this out for you guys. So a collection in Python is going to refer to any object that can group multiple pieces of data together. In each type of the collection, has a unique characteristic and serves different purposes. And what that actually means is that it is just a data structure that allows you to store and organize multiple values. And the most commonly used ones are built-in collection types like lists, dictionaries, tuples, and sets, which is what we're going to be going through here today. So how this comes in handy is from what we know, we have a variable. And let's say I have a variable called student and I want to actually store in a student's name. So here I'm going to type in Lizzie and I'm going to store Lizzie's name. And I know that in this case, I can print out student here. Here it is. Okay, I just took that off, so hopefully, okay, that's out. All right. So now that I have this student variable here and I print out student, what should pop up should just be Lizzie. And this is just a variable that is storing one value here. But let's say I want to store multiple values. In that case, I can actually use a different data structure. So in this case, I can only store one student, but let's say I want to store multiple students. So in this case here, I can create a list. So I call it students. And then I'm going to create an empty list here that's going to allow for me to place student information in here. So if we remember from the past, we know that a list, how we actually create a list is just by having the name of the list here, and we can create an empty list. We can create a list that has names in it. And we can also, after we create an empty list, just append to that. But one of the things that we really want to think about is that a list is an ordered, mutable, meaning it can change collection that can actually hold items of different data types, as you guys saw yesterday. So what this actually means is that items can be changed. That's what mutable means. And it can be duplicated. So that means you can duplicate items. So I can actually add in here Lisa again. I can also have a list of mixed values. So multiple things here. The list has, it's ordered, it can be changed, and it can hold different values as well. So now that we have that understanding, now we can take just storing one student and actually be able to store multiple students. So I can store Lizzie, I can store Ethan, I can store Chloe, I can store Alex, and multitude of individuals. So now we have a collection of string values here stored inside of our list data structure students, and I can print out students here. So when I run this now, we see the list of students. Now, this works wonderful if you are trying to store items that may be duplicated, if you are wanting to even update or change items. So, for example, if you guys remember how we update items in a list, if I wanted to change out Chloe and put another student's name in here, like Lauren, I could then do students and access with the index here. We have 0, 1, 2, 3, and then we also have a negative indexing here. 3, negative, oops, this is actually -4, -3, -2, and -1. So I can choose to have positive index, and I can also choose to have a negative index. Okay, so these are some of the things. So if I want to update Chloe, I can choose to do -3, or I can choose to do 1. And I can say that I want to update this value to be Lauren here. So now when I print out students, we see that Lauren gets, oops, which one did I do? See, oh, shifted it a little bit. Did the wrong thing. So actually, Chloe is at 2. I had it right the first time. And so now we see where Lauren is. So because Chloe is at +2 or -2 in this case, I can either choose to do +2 or I can choose to do -2 for the negative part and update Chloe to now be Lauren. So with list, we see that the structures are similar to how we would go about actually even updating in this case if we wanted to update student and a specific element here. So if I wanted to update Z, the first Z in place Y there, since it's 0, 1, 2, 3, 4, 5. So that means I'm going to say 2 here. So if I want to update Z up here, and I'm going to want to place it Y, we may see that this is, let me just print it out here so you can see. That it's not possible for me to do that. And the main difference in this case is we would like to actually update. We cannot change a string. It's immutable, meaning it has to stay the same. And if you remember from yesterday, how we do that is we actually say, okay, we want to pick the index of where we want to update. So how I go about actually updating that, so you want to understand the difference here. Let me go and put it. We have strings, immutable. So in this case, if I wanted to update Z with Y, I would have to first create students over here. We'll get rid of this. And instead of doing it how we would do with lists, what we would do is we would have the name of the variable we're wanting to update. We now have, oops, Control Z. We're now in front of this. We can do a replacement of it. So there are two options. Hopefully you can remember. The first one is student, and we're going to go ahead and use our concatenation operator here. But in student, because I just want everything up to 2, not including 2, I'm going to put a colon here and place 2 there. So it's going to give me everything up to here and get rid of this. Then we're going to place Y there. And then afterwards, I'm just going to use the student and say from index 3, 0, 1, 2, and 3. So this Z part. So we're going to include that and we want to go to the end of this list. So it's going to add that on here. This is one way to update it, but it's pretty much making a new string into student. This is one way to do that. So now when I run it, it works. We separated or we got rid of the first C and put Y. But let's also see where we can do the built-in function that's already in place with strings. So we can actually do student equals student dot replace. And let's say instead of having Y here, let's just have A so that we can see the difference. So we're going to replace Y and we're going to place in there a uppercase A just to see the difference. And then we're going to print out student. So again, this is actually just creating a new string and using the dot replace function here. So when we run it, we see that it's now changed it to Lazy, and then it was originally Lizzie. So these are the two separations from when we come from. We come from creating a variable that is a string, which is a sequence of characters, which is essentially a list of characters. Because strings are immutable, the way that we update them is we can use splicing and indexing here, but we can also use a built-in function. With lists, it is mutable, meaning it can change by using index, just like how we have here, either negative or positive. It can allow for an ordered list. It also allows for duplicates. And so we've gone through this section yesterday, and so this is just review of these two items here. Now that we've gone through list, we now want to take our time and get into what is a tuple and all the other aspects of this. For tuples, let me move down here. Tuples are an ordered, immutable collection of items. So the main features of a tuple is that it allows for us to insert in order. It also allows us to have duplicates just like lists, but it's immutable, meaning it cannot be modified after creation, but it is faster than a list. Allows duplicates. It maintains your insertion order, which is important if you do care about order. And some use cases for tuples would be, for example, for fixed data or coordinates like geological coordinates of where things are, or when you want to actually use a key in a dictionary since it's a part of a hash table, and you'll see that later. And we also can use it for RGB values as well. So in this section here, we're going to kind of go through how we can create a tuple called chords with two numbers in it. So what that looks like here, we'll start here. We'll have a variable called chords. And how we go about actually creating a tuple here is we have our assignment operator and then we have our open close parentheses. Now, this open close parentheses allows for a fixed set of data. In this case, we're going to be using it as coordinates. And so we have 40.7128, comma, negative 74.0060. So this allows for us to create our coordinates, a variable called chords, a tuple called chords here. And then the next thing we need to do is print out the first value in the coordinates. So we're going to do print, and we're going to type in chords. And then inside of this, open close square brackets here, in order for us to get the first one, we're going to type in 0 because it still follows the same process where the first item is 0 as an index and the second one is 1 as an index. So this is going to print out the first one. So now we see 40.7128. Now, the next thing we want to do is try changing the coordinates to 0. It won't allow us to because, again, just like strings, coordinates or tuples are immutable. So in this case here, if we try to change it, all right, so here's what we'll do. So in this case here, I'm going to type in chords and I'm going to try to index it with the 0 here. And then I'm going to assign 0 to this. Now this should give us an error as well. And it should say because tuples are immutable, we can't assign a new value or something of the sort here. So try changing core, it shows you the error. It says tuple object does not support item assignment. And this is again because tuples are immutable, they can't assign new values. So now we comment this out so that we don't get any more errors. There we go. And then the next thing we need to actually get into is called unpacking. And what unpacking is when you take an element of a collection like a tuple or a list, and you actually assign them to an individual variable in a single line. So what you want to think of this is actually, let's see, unpacking a suitcase is a good one. So the suitcase is going to be your tuple or your list, which is the container holding all of the data sets or values that you're placing in there. And each item in that suitcase is actually going to get placed into its own spot or its own variable. So in this case, what we're wanting to actually do, since we have 40.7128 and then negative 74.0060, what we're actually going to have here is just have x comma y, and we're going to assign to it the chords here, the values in the chords. And this is the unpacking process. All right. And then the next part of this, what you want to think about is actually just printing out X, which should print out the 40.7128. And then we have where we're going to print out Y. And that should also be negative 74.0060. Get rid of that one. All right. Okay, so now when I run this, we see that both of these do print out, and I'm going to just do unpacking. So that is what unpacking is, and I will go ahead and place that here. Unpacking is when you take the elements of a collection, like a tuple or list, and you're going to assign them to individual variables in a single line. Okay, so now we have 1, 2, 3, and 4 done. We finished, and 5 done. We finished this section and we see that everything gets printed out right. So this is one way to actually be able to work with unpacking or even tuples. So the chords is the thing that contains the two values. In this case, we have our latitude and our longitude. In this case, we're using coordinates. And then what we do is we're assigning that. So what takes the first value x is what is the first thing inside of that coordinate. And then what takes the second value y is the second item in that coordinate there. All right. And so the next thing here is now you can use X and Y interchangeably for the coordinates if you wanted to. And these can be obviously modified since they're the variables and not necessarily in a tuple. All right. So why is this actually useful? It makes for cleaner code. It's also easier to read, and it also lets you work with multiple values quickly. And that's going to be something common that we see when we get into loops as we mix in data structures, but you'll see that in a moment. Another example that we'll get into, and I'll show you guys this. This is not a part of the task, it's something separate. But we can actually store inside of our a tuple a person's information as well. It's not necessarily the best, but you can store it, and I'll show you that here. So we have person, and in person, we're going to store in Alex, and then we're also going to store in 21, and then we're also going to store in their major as computer science. Now, this has individual's data here. So this is also a way to store tuples. Just talk this is a side quest or something. Okay. And then what we're going to do now is we can actually use unpacking. So we can have a variable for name, a variable for age, and a variable for the major. And what we can do is assign the tuple person to that. So each one will get assigned a specific item to that. And then we can actually use what we learned yesterday, which is the format printing. Open, close curly braces, and we'll place in name for the name is, and then we'll have open, close curly braces again, and the variable age we'll place there. And then and studies, spell that right. And then open, close curly braces, and then inside of here we will put major. So this is also one way for us to actually use a tuple to store personal data, unpack into individual variables, and then we will format print. So use a collection to have tuple. All right. So that is another way for you to use it in a different manner that you can see separately. So hopefully you were following along with that. We will have plenty of opportunity to actually work through tuples, and I'll show you different examples of tuples a little bit later when we get into that. All right. So the next thing that we're actually going to be looking at is going to be sets. So again, it's important to know tuples support indexing, unpacking, and they also are a lot lightweight, as you can see, a little bit easier, faster to use, and it allows for you to have fixed data or fixed records that you can modify and use. The next thing that we're actually going to be looking at is a set. So a set is an unordered um, collection that allows you to store unique items only. And this is also great for membership tests, removing duplicates, or performing math-like operations. Think of it as like a bag of marbles. There's no order, but there's also no duplicates. Well, there should be no duplicates. All right. So in this case, we'll just get right into the task here. So we're going to create a set called colors with red, blue, green, and red in it. So I'm going to have my set called colors, and then I'm going to assign to it these values here. And as you can see, there's a duplicate red at the front and at the back. So now we're going to print the colors to see duplicates, if there will be any that display, and there won't be. Yeah, so here there isn't because sets store unique and unordered items. So we have red, blue, and green here. The red we see only appears once, and that's because it is duplicated inside of the creation, but they do not care. We only see one. All right, so then the next thing that we need to do is actually add yellow to that color list. And fortunately for us, there are built-in methods or built-in functions in Python here that allow for us to actually add in elements into our collection set here. So in this case, I'm going to call colors and then I'm going to do add. And I'm going to place in here in this add built-in function here. I'm going to place in here yellow. And this is just going to allow me to add an element. Now, the next part of this is I need to create a set called primary to get the primary colors with red, blue, and yellow in it. So I'm going to call primary, and I'm going to store this. All right. And then the next thing I want us to do is actually print the union of colors and primary. And the union means all of the unique elements of them. So what that actually means is we will more than likely get blue because they're both in both colors and primary. We will more than likely see green because this is a union of both. So we'll see green since that shows up in colors. We'll see red and we will also see yellow because yellow was added to colors. So in this next step here in number 5, when we want to use the union function, there is a built-in method dot union. And here, how we do it is we'll do print, and then inside of here, we'll have colors dot union. And in the open close parentheses, what we'll do is we'll put in there the primary set. And so what this will do is it will return back the union of both of these. It will turn back the union of color and primary into this specific print statement. So we see here it does print out red, green, blue, and yellow. And that's because they both show up in both of these. That's all unique elements is what union does. So it looks at all in colors and all in primary, which is here. Now, the next thing that we have to do is actually print out the intersection. Okay. We're going to do print and we're going to have colors first, as you can imagine. Then we have that dot operator to access the intersection built-in function here. And then inside of here, we're going to return or place in there as a parameter primary. Now, what should get shown should be blue, it should be red, and it should be yellow. And that's only because yellow is also a part of colors here. But we should not see green because green is only in colors and it's not in primaries. So we won't see green in there. An intersection just means the common elements here. All right. So now we see red, blue, and yellow, and we don't see green. So that is what that intersection does. Now, again, the main key takeaways in this would be the intersection union. And there's also another one that is also used the difference, and it's the item in one set, but not in the other. And I will show you that here. I'll show you that here, even though it's not a part of this task, so it will be a side quest. So in this case here, if I really wanted to use the difference, which is again a side quest, this is just going to find, for example, if I wanted to use difference with colors and I pass in primary, it's going to find what is not primary. So in this case, if I print out colors dot difference and I pass in primary, what we should see on the outside, it should be green because in primary there's no green, but there is green in colors. So we see that green does display out. All right. So we have that. And let's say, for example, I want to actually do the opposite and I want to see or tabbing over. Hopefully you remember that. And then here we have primary dot difference. And then inside of here, we're going to pass in colors. And so here, all we see is set because all of the primary colors are already in color. So for example, I know that this is not primary, but if I add in here purple and I run it, we now see that purple will present itself inside of this. But if there is not anything that's different, then it will just return back set. Okay. So that's the side quest difference here, but uh pretty much the results here is going to be it's all ordered sensitive, and one of the most important things that you want to remember for sets is that it allows for you to not have duplicates. So here we only have red, so it's unique items. So if you have a data set or a data set where it has duplicates and the requirement for you is to only have unique items, you may want to consider using sets since it already has the built-in feature in there that only spits out one version of that item and not multiple. It also focuses on it's unordered. So if order doesn't matter and unique items is, you know that you would quicker use sets. This is very good for membership tests, removing duplicates, as well as performing math operations. And you may come across some of these for discrete structure, like I know union is for or, and intersection is the and part, meaning everything included. So this is just different mechanisms, a way to use sets. And again, we will run into sets multiple times, and you'll run into different ways to use sets as well. But there are ways that we can add items like we see here with adding in yellow. And then obviously we perform union or intersection here. There is no indexing, but you can use in to test your membership for it. So now we will move on to dictionaries here. So with dictionaries, one of the things that you want to remember is that a dictionary is a map that has keys to their value set. So each key are unique and the values can repeat itself and it is perfect for fast lookup. Some of the things you want to think about is like a real dictionary. There's a word, which is the key, and that maps it to the definition, which is the value. And so in this case, that is how I want you to think of a dictionary, okay? Actual dictionary. So in this case, what we'll do is create a dictionary called student. We'll do that. And we also need to be able to have key values. So we have a key, and how we create a dictionary is we'll use an open close curly braces here. And for the key, it wants us to have the name. And I'll show you that. We'll have a name for that. And then we're also going to have a value. And so here I'm assigning name. And then I'm also going to assign to that a value. And in this case, it's going to be Alex. So I also want to have in their age. So this is the first part, the key value pair in a dictionary. But I'm going to also now add another key value pair. So we have age. And we can actually put it as an integer here. So we have our key being age and our value being 20. Okay. And then lastly, we'll have a major. And then we'll put CS here, for example. So this in and of itself allows us to store in a key value pair. So we have a name, age, and major. So now that we have our name, age, and major, we now want to actually print out the value of age with that key. And how we can do that with dictionaries, and it might be very similar to what you see for lists, is we're just going to do print, and we're going to have the name of the dictionary, open close square brackets here, and then inside of that open close square brackets, we're going to place in their age, which is the key to the age that I want to display. So it's going to actually display the value here. So when I run this here, we see that it displays 20. So the difference here, if you notice, with a list and a dictionary is the key is what we place in the open close square brackets, whereas with the list, how far up does this? Okay. With the list, we just have to use the indexed value to be able to update that value there. Dictionary. All right. So now that we are at this point and we've placed in the key to display our value, we now want to be able to add a new key with a value of sophomore. So how we go about adding a new key with dictionaries is we actually can update it just in the same way we've done for lists. So we have student, open and close square brackets. The square brackets inside of there, we need to place the key. So in this case, we're going to say we want year to be the key. And then we're going to actually update it by using our assignment operator. And we're going to place in there sophomore. Can you spell that? Okay. Sophomore. Then afterwards here, the next thing that we want to do, and I'm going to actually print out student, the full dictionary. And you'll see here that we have the name, the age, and the major, which we had here. But we've also updated and added in a key and a value pair here. So that's year and sophomore. If you notice, when we do it like this, it automatically updates it to this list here. So the next part of what we're going to do is actually delete the major key. And there are a few different ways in how we can actually delete. Oh, wait, we need to go back to update the age to 21. Okay. So actually what we're going to do is update the age to 21 before we get into actually deleting the major key. So how we go about actually updating the major or updating the age is we will just do the same thing that we've done here with sophomore. The only difference is we'll just do it with age. So, or what we did with yeah, what we did with that. So here we will have student, open close square brackets, and we'll place inside of here the open close square brackets age, and then we will assign to this 21. Now this allows for us to actually see the update here. So age is no longer 20, it's 21. So we see the update. Okay. So now that we've updated age, we now want to get into deleting major. Now the delete major here, there are a few different ways that we can actually go about doing that. So something that you similarly saw yesterday with lists is we can actually use pop to remove major. Pop removes the actual key. And then it gives you back, oops, okay, gives you back its value if you want it. So pretty much returns the value to it if you want it. So it's similar to yesterday when you used pop, it returned that element to you, but it removed it. If the key doesn't exist, then it will raise an error. So, and this is just unless you provide a default. So in this case here, how we go about using pop is I can do student.pop similar to yesterday. The only difference is instead of putting an index, what I'm going to do is I want to put in the key that I want to pop. And in this case, it's going to be major. So that is going to get rid of major. And then when we print out student, we'll see that that will no longer be there. And since it returns its value, I'll just put value here so we can see it. And we'll print out. So here we see the value is CS because it returns something. We can store it directly into a variable and then print that out, or we can just have it be as is. And so we see here it just prints out student and whatever gets returned gets returned. We don't really care. It still removes it though. So this is one way to delete major or delete the key here. The other way is actually pretty simple as well. We would use the delete, direct delete. This is what it's called. And this just removes the key immediately. So we can use delete student, open close square brackets, and then do major. Removes the key immediately. There we go. And it only raises an error if the key doesn't exist. So then in this case, for the pop portion, it will raise an error unless you provide a default. For delete, it will raise an error. So then in this case here, let me just show you how you can actually provide a default for pop. Do. So you can do student.pop, and let's say I have in here grade. And when I run this, let me just comment this out real quick. And actually, yeah, I'll just do grade. It raises an error with that. So what we want to do instead is just give a default that says none. And that default, it won't crash if grade is missing. So now we see it didn't crash. So if, depending on the mod, the the specific function that of your program that you want to use, if you specifically want to make it so it doesn't crash at all, even if it's the wrong error, then you could use pop and have a default value. If you don't really care either way, you can just do delete student and it will raise an error if that's not available, if you do care about that part. So I'm going to comment this out so we can actually see the direct delete first. So we printed it out first. We see that year is there, and then when we use delete student major, that happens. So it works well. If we change this to be grade, it's not going to delete major. And we see that it does throw an error here. So this is another way to use it. Uncomment this, student pop delete. Okay. So there's another item that is similar to pop. It's called pop item, and that just is going to remove and return the last inserted item inside of your dictionary. And we will get to that later, but I'll just place it here so you can see. And I believe this one is for everything that we're doing up in this classroom. So Just say student pop item. So for this one, you don't actually necessarily need to place in there anything. It's just going to remove the last one. So when we run it, oh wait, I gotta hide this one. And which one deletes to? Okay, and this one because it's already deleted. All right, there we go. So we are at the second one of pop. So when you see pop item here, it actually did pop the last one, but let's go ahead and comment out the major. Oops, okay. Run. And so we see here, it just pops the last item, which the last one we added in was year. So that's what pop items does. Okay. All right. Side class. Dip. Okay. So now that we're done with this part, I'm going to move on to this next part where we finish deleting the majors. So we're finished with deleting items. All right. So now the next thing we're going to do is print out all the keys as a list, print out all the values as a list, and then print out all the updated dictionary. So hopefully this part will be, let me just see which one raises it. The delete one. Okay. Comment this one out. So the next part of this, we will actually look at printing out all the lists and all the keys in the list. And some of the things that we've used in the past, we will see that we can use it again. But there's also a built-in function here that we're going to be using that's different, and it's the keys function. And there's also very similarly to that as well a values built-in function. So for us to be able to print out all the keys as a list, if you remember, if we put everything together that we've thought about, we know we're going to have some print statement. We also know that there is a function that's called list that we used yesterday to group things together as a list. So, and we also know that we have a dictionary. If it says print all the keys as a list, we have a dictionary that's called student. So we know that we have that. So now that we know that we have these three here, without even knowing this part, we can have our print statement. We know that we're going to use lists to host whatever is in there. It should be lists, not lists. And you'll see that be blue there to indicate that it's built in. Then what we're going to do is we know we have to pass in some sort of value into a list for it to create whatever it is being passed in as a list. So we put in student. So now that we have our dictionary, our list, and our print, it should work. However, because the instructions say all the keys, we don't necessarily just want the name and the age. We want all the keys. So let me also get rid of those because I don't want this stuff to pop up. Need a full delete major. Okay. Let's run. All right. So yeah, we have the name, age, and year, but we want to specifically look at all the keys in this case. So we're going to do dot keys. And this should display in the same way name, age, and year. So let's run this, and we see that it does display that. Now, if you noticed, when you just printed out the dictionary, it does just only print out the keys. But if you specifically only want keys, you would just do dot keys. Now we notice that it doesn't print out values when we just do print list student here. It prints out the keys here. So in this case, what we're going to do is now try the value part. So we know that we're going to have our print statement. We know we're going to have lists. We also know we're going to use our dictionary name. Now let's look at the built-in function values. Now this is going to take all of the value parts. That's the Alex, the 21, the CS, the sophomore, and it's going to make that a list. So we should see Alex 21 sophomore. This is one list here. Then what we want to do is just when you print out the updated list, we would just print out, or the updated dictionary, we just print out student. And what we should get is what we've had so far since we've been printing it out. So we know that we accomplished the last step, the seventh, eighth, and all of these steps here have been completed in this one section. Okay. All right. So now that we're done going through dictionaries, you will have a plethora of opportunities to maneuver through these data structures, but that's just it for that. We also have functions that we'll get into called get, where you can get a key might be missing, and so you can get the value through that. You can also use for loops with the dictionary, and we'll get into that when we work on for loops as well. All right. So the next portion of this that we're going to actually get into is the common data types summary. So now we've finished with those data structures, kind of introducing them to you, and we've kind of understood that dictionaries, they must be unique. So when you're adding in a key that already exists, it will actually overwrite that value. We also understand that a dictionary has key value pairs. So it stores data in pairs, so it's easier for faster lookup. So instead of potentially maybe even using sets for individual information, we could potentially use dictionaries since it does come with pairs. It's very mutable and it's dynamic. You can add, update, delete items at any time. Um, there is no order guaranteed in terms of the way that you insert it into a dictionary. So when you insert it, it may be the first, it may be the last, it may be in the middle. There's no set order. All right. So this is just going to be important to know for the common data type summaries. We have a string text. This is a literal text value. We have a list. This is a literal list value of values from 1 to 3. We have what's mutable and what you, if you can use indexing or not. And then we also have the typical use of it. It's kind of like the use cases of it for each collection or data type. So I hope that you can kind of grasp which one you would use for what based off of today's lecture. We also have a quick check, so I'd highly recommend you kind of checking to see which one of these would be the right answer for the actual data structure that you would use. I will be uploading the answers to these code with me's as well. So you'll be able to check to see if you were right or wrong for these quick checks. The next part of this is the converting basic or between types to fit our specific task. So this is more so just review on things that we've kind of already gone through. So in here, we're going to create a list, nums, and we're going to store inside of here 1, 2, 2, and 3. Then we're going to print out float, which is going to be 7. So we're going to use the float function to print out 7. And we're also going to print out the integer value for 3.9. So we're using the built-in function float to typecast, and we're going to use the built-in function int to typecast as well. Then we're going to run this and then do the All right, so what's going to happen here? We may see, for example, with 7, it should be 7.0. For 3.9, it should just go to 3, meaning it will get rid of or truncate, which is another word that you'll see, truncate this decimal. So it does not actually round, it just gets rid of or truncates the decimal here. So the next part of this, after we've done 1 and 2, is we're actually going to remove duplicates from num by converting it to sets. So for example, if I were to say, hey, create a list, and then I say remove duplicates, and I don't tell you the rest of this from nums by converting to sets, then back to a list. What you need to think about is how do I remove duplicates from this list? Not manually, but using the tools that you just learned. So here I would just have nums no dupe as the variable. And then I'm going to assign to it, I'm going to use the list to convert it, that list or the set to the list. I'm then going to use the set so that it gets rid of that duplicate. And inside of the set, I'm going to pass in the list nums. So here's what's happening. We're passing in the list num that holds the 4 data points, 1, 2, 2, 3. This set is going to convert that list into a set, and it's going to get rid of the duplicate. Then all of that value is going to get returned here, and it's inside of that list built-in function. So after it's converted that list into a set, is now going to convert that new list or that new set into a new list. And then we would actually see when we print out nones, no dupes, we will see that new list without the duplicate as a list. If you prefer, you can separate it. So we'll have sets here. And I'll plop this in here. And then we'll create new list equals, and we'll do a list and type in sets. And then we'll do print new list. Now this does the exact same thing that these 2 lines do. It's just separated a little bit more so that you can see the process and the steps. So I'm gonna this and comment this so you can see. And we see here it does the same thing. So if it works better for you to do this, then do this. If it works better for you to do that, then do this. You just need to develop your own programming style. All right. So now that we have this section here, what we're going to be looking at now, we've removed the duplicate from nums and converted the sets back to a list. Now, and we've printed the deduplicated list. And then we're going to print out nums as a tuple and as a set. So again, in the same way that there is a list built-in function and a set built-in function, let's take it one step at a time. It says print nums as a tuple. Let's go ahead and do that. So we know how to print. We'll do that first. Now we know that we're going to need nums somewhere in here. So we place nums. But the next thing that it says to do is as a tuple. Since there is a list function, there's a set function. Now we're going to look at the tuple function. So we'll use tuple, open parentheses and close parentheses. So now tuple has our open and close, print has its open and close. We have now successfully print out the list nums as a tuple after we successfully do it. There we go. So now it's as a tuple. It stores 1, 2, 2, 3. And remember, the only reason why we're still seeing that 2 is because we reassigned it to a new variable that updated list with the new duplicates. So this one is taking the original list that you had with the duplicate and plopping it into a tuple. Now, the next step of this, it says to do is do the same as a set. So since we already know how to do that, we have our print, we have our set, and now we're going to pop in here our nums. So we're also going to see that. And there we go. Then it prints it out as 1, 2, 3. And remember, with sets, there's no duplicates, so it automatically gets rid of that extra set there. So essentially what's happening here is actually what is happening inside of here before it converts it back to a list. So that's it for this type conversion review. Hopefully you were able to get this working for yourself. Oh my God. There we go. Now the next part of this, and this is just review again. The next part of this is actually going to be using the binary. So first things first, this is review on binary. We're going to print out the binary representation of 42. And hopefully you guys can remember there is a built-in function called bin. There's a built-in function called int. So in this case, if I want to print out the binary version of 42, I'm going to use the bin built-in function and type in 42. And then I should see this is the binary version of that. Okay. Then the next thing we see, convert the binary string of 101010 to a decimal integer. So if you remember when you guys were converting your initials and also decoding the binary string from the last assignment, here now we're going to have the decimal value. And I'm going to use the int built-in function. So the very first part of that I'm going to place in is the string 101010 for 42. Then I'm going to have comma and say that I want it to be of base 2 here. Now that we have this being base 2, the next thing we want to see is just it being printed out. So we're going to print out des value here. Now we have it being 42. So we see that it has converted it properly. The very last thing that we're going to look at, and this is a little new intro, is the formatting the number 7 as an 8-bit binary string with leading zeros. So in this case, if you want to format 7, what you'll do is I'll just say format bin equals, and we'll use format function. Now, this one is also considered a bit of a side quest, even though it's part of the task. However, it may come in handy in the future. So we have format, and then we're going to put 7 as the first parameter. After that, though, we're going to indicate um, that we actually wanted to have the 08B in front of this. And this allows for it to be the 8-bit binary string. Now, let me get this. The B we know would be the convert to binary aspect. This is the format specifier that we're specifically expressing the format of what we want. Then we have 08, which just makes it 8 characters wide. And then the padding with zeros on the left. So if we have the leading zeros here, then we have the 8-bit, and then we have convert to binary. So now what we should see for 7 shouldn't be this part here. Oh, after I print it out. Don't do that. Format, bam. There we go. All right, now we have 7 as a 8-bit binary string with leading zeros. So we have the first 4, then we have the last 4. All right. So the very last part of this, I want you guys to try your hand at it. Try your hand at the Real World Challenge, the Mad Lib style, as well as the Extra Challenge, because this will definitely come back up in one of the future activities. So please try your hand at this. And then we will be coming through next activity with something fun and exciting as we go through these different data structures. So please study list, tuples, sets, and dictionaries, and just test it out. The best way to learn code is to try it out yourself and code it yourself. So after you've submitted this, try out whatever you'd like to try out. Look at the different functions associated with these different methods and look at the Zybook as well, because there are going to be a plethora of functions that are associated with these different collections that we won't have time at all to cover within this class. So anyways, I hope that this lecture was clear for you and that you understood these concepts. If you have any questions, feel free to let me know and take care. And see you later.